Yeah, hello everyone. We now continue from the previous lecture that was stopped due to some technical glitch. So, as promised, I just started in some 3 or 4 minutes again. Thanks for joining everyone. I'm sharing the link again so that all can join. Tell me if there are any problems you encounter while watching the session. Now, ah, we had finished a quite good portion of the chapter. Now we have arrived at operations on events set theoretic approach to probability. Okay. For example, a die is rolled once, then the sample space is given by this. We already told. If a die is rolled, then the sample space is this. If we define the events A, B, C such that A, X is an even number of points in S. Okay. Event of even number occurring, B is event of odd number occurring, and C is an event of multiple of 3. Multiple of, so A can be written as 2, 4, 6. B can be written as 1, 3, 5, and C can be written as 3, 6. Okay. Now, if we talk about mutually exclusive events, then A intersection B, if we do, we get nothing. That means A and B are mutually exclusive. But if we combine A and B, we get everything 1, 2, 3, 4, 5, 6, all. So A and B are exhaustive also, because after combining them, we get everything. If after combining two events or more events, we get everything, then those events together are called exhaustive events. Okay, exhaustive events. Now, classical definition of probability. Let us consider a finite sample space with a finite number of sample points. We assume that these sample points are equally likely. In an event A, which is a subset of S, contains n A sample points. Okay. In simple language, S was 1, 2, 3, 4, 5, 6. A was 2, 4, 6. So 2, 4, 6. There are three things that tallied with S. So NA, number of events in number of elements in A is 3. NS is equal to 6. So probability of A is Na by Ns. Na by Ns is the formula. Probability of occurrence of an event E is Ne by Ns. Okay. That is the classical definition of probability. Now union of two events, intersection, union of two sets, intersection of two sets, I have already talked about. So we'll see examples. Example 13.8. Three events A, B, C are mutually exclusive, exhaustive, and equally likely. What is the probability of the complementary event of A? Mutually exclusive, exhaustive, and equally likely. When we talk about mutually exclusive, exhaustive, and equally likely, let me tell you a few things. If we discuss the set theoretic approach, then mutually exclusive events, probability of A intersection B is equal to 0. Exhaustive events, probability of A union B is 1. Okay. Mutually exclusive events, probability of A intersection B is 0. Exhaustive events, probability of A union B is 1. equally likely events. Probability of A is equal to probability of B. Equally likely events. Probability of A is equal to probability of B. Mutually exclusive events, exhaustive events, and equally likely events. Now we have addition theorem. Addition theorem that any kinds of events, doesn't matter, any kinds of events, PA union B is equal to probability of A plus probability of B minus probability of both together. That means intersection. This is the addition theorem. So what will be the case in case when there are exclusive events? When there are exclusive events, this part will be 0. That means this part will be 0. So for exclusive events, probability of A into union B is equal to PA plus PB. For exhaustive events, probability of A union B is equal to 1. That means PA plus PB minus PA intersection B is equal to 1. For exclusive and exhaustive, for exclusive and exhaustive, this will be the case again, and also this part will be 0. Then we'll have PA plus PB is equal to PA union B is equal to 1. Okay. Then equally likely, PA is equal to PB. That means if events are exclusive, exhaustive, and equally likely all together, exclusive, exhaustive, and equally likely all together, then PA plus PB is equal to 1, and both these are equal. That means PA is equal to 1 by 2, PB is equal to 1 by 2. If there are three events PA, PB, PC, then PA plus PB plus PC is equal to 1, and all these are equal. That means 1 by 3, 1 by 3, 1 by 3. Okay. पूछ रहे हैं कि आफ्टर वन क्या लिखा है वीडियो के टाइटल में। अभी इससे जस्ट पहले 1 घंटे का एक सेशन लिया था, इससे जस्ट पहले 1 घंटे का एक सेशन लिया था, वो बंद हुआ, उसको बंद करना पड़ा ड्यू टू टेक्निकल प्रॉब्लम, वहीं से कंटिन्यू किया है। दैट इज रिटन इन द वीडियो टाइटल। ओके, you'll get to know that later. Let me continue the video. So if there are three events, exclusive, exhaustive, and equally likely, that means all three have the probability equal to 1 by 3. Okay, so three events A, B, C are mutually exclusive, exhaustive, and equally likely. What is the probability of complementary event of A? So probability of A is also 1 by 3. So not A is 1 minus 1 by 3, that is 2 by 3. Not A is 1 minus PA, that is 1 minus 1 by 3, so 2 by 3. Axiomatic or modern definition of probability. Modern definition of probability. PA is greater than or equal to 0 for every A. Okay. PA is greater than or equal to 0. PS is equal, S means sample space. PS is equal to 1. Okay. When we are talking about mutually exclusive, that means simple addition, nothing common will be there. Okay. Now, addition theorem that I already told you. But when we are talking about mutually exclusive, then it will be the case that also I told you. Now, a number is selected from the first 25 natural numbers. Uh, Someone has asked, sir, please give tricks to solve probability. That's what I am doing right now. We are discussing probability from the very basic. From the very start, I have started with the random experiment, trial, outcome, event. I have started with the definitions. Now I am discussing the chapter, and I am also discussing the examples, and thereafter we'll go after we'll look after the tricks. Okay, whatever you call them, we have to discuss it from the basic probability to theoretical distributions portion. We will do this in some 3 or 4 days. Okay, today this lecture will uh, right now it is 12:22. This lecture will end around 1 or 2 a.m. Okay, so a number is selected from the first 25 natural numbers. First 25 natural numbers, that means 1 to 25. What is the probability that it would be divisible by 4 or 7? But 4 or 7 cannot be together because a number which is multiple of both 4 and 7, the first number is 28. 28 is beyond 25. That means from 1 to 25 we don't have a number which is multiple of both 4 and 7. That means these two are mutually exclusive events. That means this formula will apply. So multiples of 4 are 4, 8, 12, 16, 20, and 24, 6. That is total 6 numbers, and thereafter 7. 7, 14, and 21. 3. 6 and 3, that is 9. So 9 by 25 is our answer. A coin is tossed thrice. What is the probability of getting 2 or more heads? Sample space is already there in front of you. 2 or more. 2 more. 2, 2, 2. So there are 4 cases. 4 by 8 is our answer. 4 by 8 is our answer. 3 by 8 plus 1 by 8, that is 4 by 8, 0.50. We have got comment, sir, please put all videos of probability in a playlist. Yes, that will be done, but let me finish the session at first. Okay, that will be done, but let me finish the session at first, because right now I am right now I am taking this lecture. So at least when I will finish the lecture, then only I can add the video in a playlist. Okay, so I request you to have patience. Now we'll see for any two or more than two exclusive events, the probability that at least one of them occurs is given by the sum of individual probabilities. At least one. Whenever you see at least one in this chapter, at least one means union. Okay, union. You can see union symbol. So whenever you see at least one, that means unions. And when we are talking about mutually exclusive events, then there is nothing common. So direct addition applies. That is the addition theorem. Okay, extension of addition theorem. For two events A and B, the probability that either A or B occurs, either A or B is also at least. Okay, is given by the sum of individual probabilities less the probability of simultaneous occurrence. This is the addition theorem, actual addition theorem. I told you here. mm, this is the addition theorem, and all these are extensions: exclusive events, exhaustive events, exclusive and exhaustive, and thereafter exclusive, exhaustive, and equally likely. So now 13.11, a number is selected at random from the first 1,000 natural numbers. What is the probability that it would be a multiple of 5 or 9? 5, only 5, only 9, and 5 or 9, and both. 1,000 is equal to 5 into 200, so 200 numbers are divisible by 5. 9 into 111 and 1 remainder, so 111 numbers are divisible by 9, so 111 by 1,000. Okay, a intersection b, that means 5 and 9 both, that means 45. So 45 into 22, 22 numbers are divisible by 45, that means 5 and 9 both. So this is the pa, then pb, then pa intersection b. By addition theorem we get pa union b is equal to pa plus pb minus pa intersection b, that is 200 by 1,000 plus 111 by 1,000 minus 22 by 1,000. Okay, this is what is done here. Now 13.12, the probability that an accountant's job applicant has a BCom degree. Yes, take a look at this example. Accountant's job applicant has a BCom degree is 0.85, that he is a CA is 0.30, and his both is this. Out of 500 applicants, how many would be BCom or CA? BCom or CA means A union B. A union B. Okay. If we if we say that we will represent BCom by B and CA by C, then B union C is what we require. B union C we require. So probability of B is 0.85 plus probability of C minus. This is the addition theorem only, nothing else. This is the direct application of addition theorem, nothing twisted. Okay, so PA plus PB minus PA intersection B is the formula. So 0.85 plus 0.30 minus 0.25, then we get 0.90. Okay. Thereafter 13.13, PA minus B is equal to A minus B. Let me tell you, A minus B. A minus B means PA minus PA intersection B. You have to remember this. Okay. A minus B. And when we will study the set theory chapter, this will be very clear to you why A minus B is like this. Okay. So PA minus B is this. PA is 1 by 3. So if we are given with these two, you know that we by putting these two in the formula, we can get this PA intersection B. And now PB is also given. So A is given, B is given, and this can be obtained by the formula. That means we can obtain the A union B also. Only B. We need only B. That means we need B minus A. B minus A is what? PB minus PA intersection B. So first we have to find out this one, and then we have to put that here. Okay. We have to find out this one, and then we have to put that here. So PA minus B, that is equal to this. Yes. You can see they have used this formula. I just told you this formula. Okay. I just told you this formula, and hence it will be A intersection where B will be 2 by 15, because when we put 1 by 5 here and 1 by 3 here, P intersection B becomes 1 by 3 minus 1 by 5, that is 15, 5 minus 3, so 2 by 15. Okay, now 2 by 15 can be easily put in this. So PB is 1 by 2, 1 by 2 minus 2 by 15. We get LCM 30, here 15, and then 4. 11 by 30 is our answer. 11 by 30 is our answer. Okay. Theorem 4. For any three events A, B, C, the probability that at least one of the events occur for any three events. For any three events. Please note that it is not exclusive, not exhaustive, not equally likely, nothing special. For any general three events without any given condition. For any three events A, B, and C, the probability that at least one, that means union, at least one means union always. I told you this particular point many times today only in this video, so please memorize that at least once or at least one means union. So P A union B, we knew the formula. When there are three, then the formula is like this: PA plus PB plus PC minus this one, then again minus, and then plus. Okay, single we have to add, double we have to subtract, and then all three together we have to add. This is the formula, and this is the memorizing technique also. Singles we have to add, double we have to subtract, and all three together we have to add again. Okay, there are three persons A, B, and C having different ages. Three persons A, B, and C having different ages. The probability that A survives another 5 years is 0.80. B survives. Yes, you read this example. I'll give you a couple of minutes. Okay, if you cannot see, then I'm zooming this portion. Now I think you'll be able to see that. B survives another 5 years is 0. So this question is about survival of people for next 5 years. Survival of A, be it survival of B, be it survival of C, be it survival of all together. Okay, the entire question talks about 5 years, 5 years, 5 years, 5 years. That means mm, be it was for example, we can say let it be 50 years, the question will not change, the essence of question will remain same, the solution, the strategy, everything will remain same, and it doesn't make a change if the data is different, 5 years or 6 years or 15 years or 50 years, that doesn't matter at all. Okay, the question is only about survival, and all the years data is same. That means it is just a probability question of probability of occurrence of any particular thing. Okay, so pa is 0.80, pb is 0.60, pc is 0.50. A and B both, A intersection B is 0.46, B and C is 0.32. A and C is this. All together is 0.26. We have the formula just here. We have to apply only PA plus PB plus PC minus both minus both and plus all three. So they have added it like this and we got the answer 0.90, straight and simple. Okay, straight and simple. If there are any problems, if you didn't understand the question, you can mention that in chat. Okay, anything related to this question, anything related to the question being discussed right now, mm, can be raised as an issue in chat. Okay, there's a question in the chat. Is it for CA Foundation? Yes, it is for CA Foundation. It is also for CSAPT. It is for SSC students. It is for banking students. It is for Standard 12 students. It is for CAT. Any course, any suitable course, any course which includes probability as a chapter for all those students, it is suitable. Okay. So this video I'm taking this one from 11 p.m. That means some 1 hour 40 minutes ago. This is second video because the first video stopped when the clock struck 12. The day changed and there was a connection glitch, so we had to close the previous video and we started another video. This is a marathon lecture. That means we'll discuss many topics of probability, and we have achieved that target already. We discussed the basics of probability, we discussed theory portion of probability, we have solved till now 14 examples. We have talked about set theoretic approach, classical definition to probability, statistical definition to probability. Okay. And I will entertain only relevant queries. Only relevant queries. That means if I am discussing example number 14, then you have to talk about example number 14 at that point of time and nothing else. Because if I start talking about other topics, it will deviate us from the context. If I'm talking about example number 14, then you have to talk about example number 14 only. You should not ask at this time that, sir, how to prepare for CA Foundation within 2 months. For that, I have already given you my WhatsApp number several times, 8294600829, and there you can discuss such things. Yes, for WhatsApp only, not for call. On this number, if you raise a query, then yeah, without mentioning your name or anything, if you just raise the query, you will get a positive response within 24 hours. It is highly likely that we answer you within 24 hours. I can't guarantee, but I can assure, I can say that we try our best to resolve your queries within 24 hours. Okay. So if you have any queries which are not relevant to this particular thing which is visible on your screen right now, you can ask on this number by sending a WhatsApp text. Okay. Uh, Now we move to the next section, uh, conditional probability and compound theorem of probability. Conditional probability and compound theorem of probability. The probability of an event discussed so far is technically known as, let me tell you about compound probability in simple terms without discussing this written text. This symbol, this presentation, this notion, when we use this, it is read as P B given A, probability of B given A, B given A, B comma given A. People read it like B given A. It is completely wrong. You must pronounce it like probability of B, probability of B given A. Probability of B given A. Given A means A is occurring definitely, or A will occur definitely, or A has already occurred. Given A means A is sure. No one can stop A from occurring. That is given A. Okay, when we talk about B given A, that means we need to find the probability of B when A is already occurring. So we are talking about what? We are talking about probability of B when A is given. So there's another text. If we solving Go probability, it takes a lot of time. That is the difference of approach. That's why we are taking this lecture right now. That's why we are taking this lecture, because for the students, this particular chapter is quite difficult, or as they say, I am not telling that this is difficult. Students say that, sir, this chapter is difficult. Please discuss this chapter. So I am discussing this chapter right now. For that only, we are discussing this. So yes, maybe it takes a lot of time till now, but when you watch my lecture, then you must get benefited when you practice the questions after watching our videos, after watching the approach we use in our problem solving. Then you will get to know that the time has reduced. It will no longer take a lot of time, as you say that. Okay, so we were talking about PB given A. So formula for this is PB intersection A by PA, or B intersection A or A intersection B are the same. So we can also write like this. And when we talk about this was B given A, when we talk about A given B, PA given B is probability of A intersection B by PB. So to memorize, remember that after this oblique sign, something which is after this oblique sign, that will be in the denominator. The same thing will be in the denominator. Uh, at first we had a few texts like please give tricks to solve probability questions. Then again we have a text, give some tricks to solve the sum. Understand what I'm telling you. At first we discussed basics of probability, definition, then theory, then we started examples, then we will finish this chapter, then we will start solving the problems, and thereafter we will discuss the tricks also. I told you that this entire session of probability will take around at least 3 4 days, or maybe a week or a couple of weeks to be finished. So please have patience for some time. We are discussing the chapter right now, and when we finish the chapter we will do a lot of examples, then we will start doing questions, and then we'll learn how to do the questions quickly. Okay, probability is something which is very important to understand theoretical distributions, normal distribution, chi-square distribution, standard normal distribution, binomial distribution, Poisson distribution. So not only the chapter 13, the basic probability chapter, the probability, theoretical distribution, sampling, all these are interlinked, and if you don't understand probability well, you just learn some tricks, you will lose 3 chapters at once, and that means you won't score in in statistics section. Okay, Out of those 40 marks, you will get hardly some 10 or 12 marks if you don't understand this particular chapter from very very basic. Okay, so that you have to understand. That's why we are going in our well defined way that we have planned. So right now, as I am telling you, I just started this video today only at 11 p.m. That means today uh, actually, the day has changed. We started it on 10th April and it is now 11th April. Okay. So we started this session 2 hours ago, and in 2 hours we have reached quite a good length of the chapter. So we must understand that it will take some time to finish. Then when we finish the chapter once, then we'll start doing problems, and we will eventually learn the tricks to solve the questions. Okay, uh, now these are the formula. P b given a is pa intersection b by pa, because a is here after the oblique sign, so it will be in the denominator. Here b is after the oblique sign, so it will be in the denominator. Okay, and provide, obviously provided that p is greater than 0. A cannot be equal to 0, otherwise it, if this will be 0, if this will be 0, then it will be not defined. Okay, and if probability of a is 0, then how can we say p be given a? Given a is impossible then, because a is an impossible event, that means it cannot occur. So how can we say p be given a? Okay, so anything which is in the denominator can never be 0. Okay, now uh, as an example, if a box contains 5 red and 8 white balls, 5 red and 8 white balls, and two successive draws of 2 balls are made from it without replacement. You have to understand this particular thing: without replacement and with replacement. Without replacement and with replacement. Say there are some balls in a bag. Okay, or we can say there are 52 cards, 52 cards in a well shuffled deck of cards. Now I drew a card from the deck. I checked it out that it is a king of spades, but I didn't return it in the deck, and I kept that in my pocket instead. Okay, I didn't return it to the deck, I kept that in my pocket. So now the remaining deck has 51 cards only. And if we make another draw from that remaining deck, then probability of occurrence of a particular card will change. Okay, if earlier the probability was 1 by 52, now the probability is 1 by 51, and the probability of occurrence of king of spades is 0, because that is not in the deck, that is in my pocket now. So this was the case of without replacement. But if the case is of with replacement, then we drew the card, we checked it out that it is king of spades, we returned it to the deck and shuffled the deck again. Now the if we make another draw, the probability is still remain the same. That was the case, which was the case in the first draw. Okay, so two successive draws of 2 balls, and made it without replacement, then probability of the event second draw would result in 2 white balls, given that the first draw. Okay, two successive draws of 2 balls, two successive draws of 2 balls, that means 2 balls are drawn every time. Okay, 2 balls are drawn every. Given that first draw has resulted in two red balls, first draw has resulted in two red balls. That means in the first draw, the balls have reduced to three red and eight white, because earlier there were five red and eight white. Now we have drawn two red balls, so three red and eight white. Now we have to find the probability of, we have applied the case. We have applied the case. Now we have to find the probability. The second draw would result in two white. Two white we have to find. So 8C2 by 11C2. Okay, 8C2 by 11C2. In the second scenario, mm, if the occurrence of the second event B is not influenced by the occurrence of first event A, then B is known to be independent of A. For example, for example, uh, if the draws were made with replacement, if the draws were made with replacement, then the first draw would not affect second draw at all. That means the first event A is independent of second event B and vice versa. In case of independent events, we say PB given A. Whatever given A doesn't affect at all, because we have to find the probability of B, and the condition is that A is given. And if these two are independent, if these two are independent, that means these are not connected, these two are independent. So doesn't matter A occurs or not, the probability of B will remain the probability of B. So when the events are independent, independent means what? The occurrence of one particular event doesn't affect another event. That doesn't mean the probability of the event will be zero. That means it doesn't affect. For example, if it will rain in South Africa right now, then what is the probability of Chennai winning and winning this IPL again? You see what I want to discuss, what point I want to make. If it will rain in South Africa right now, what is the chance of Chennai winning this IPL? This question is bullshit, because these two things are not connected. The say that chance of Chennai winning this IPL again is 0.3, it will remain 0.3. Raining in South Africa won't change it, and that won't make it zero as well. Okay, so such events are called independent events. That means occurrence probability of occurrence of B will remain the probability of occurrence of B. Occurrence of A will not make a change because the two events are independent. So in case of independent events, the formula becomes much easier, like this. Given A is just kicked out because these are independent. Okay. So in case of independent events, PB given A is equal to PB, and hence we get a formula. This formula is uh, theorem of compound probability. Theorem of compound probability. It is multiplication theorem, basically multiplication theorem, and it applies only to independent events. Okay, it applies to independent events only. There's a request to change the pen color. The request was made very late. Okay. We'll try to keep this in mind to keep the color of pen. black or red from the next lecture, but that feedback would be expected in the very beginning of the video. Okay, in the above example, okay, the balls are drawn with replacement theorems of compound probability. Okay, now we are in some to completely new topic, that is a compound probability and conditional probability and compound theorem of probability. Okay, so now as I said, the video will end at 1 a.m. or 2 a.m. Today I am concluding this video. In the next video we will start from compound probability and we'll try to finish the topic at least. Okay, this particular topic um, is very big alone. Okay, so we'll try to finish it in time, and I am assuring you that we will uh, finish entire probability section in at most a couple of weeks. Okay. Mm. So it we started it on 10th April. That means we can say that we started it yesterday, but that is 2 hours ago only. Okay, so now we have discussed a very good length of the chapter, and we'll continue it for the next few days. Okay. If there were any technical problems, if there were any feedback, anything you have to say, you can WhatsApp us on 829 Okay. So thanks for watching this video. Don't forget to like, share, and subscribe. That is very important, because if you have not subscribed yet, that means you are not getting notifications in time. Okay. So thank you so much. Happy learning. Bye bye.